This question's asking us to draw on our knowledge of the relationship between position, velocity, and acceleration. So remember, velocity is the derivative of position with respect to time, and acceleration is the derivative of velocity with respect to time. So let's have a look at this. We're told here that the object moves in a certain way, and this is the position of the object. And then we're asked to find the initial position, velocity, and acceleration. So let's start off with the initial position. Remembering initial means time equals 0. So we'll write that down. So therefore, the initial position will be x at time 0, which is 2 times 0 cubed minus 3 times 0 squared plus 8 equals plus 8 meters. Remembering that position, velocity, and acceleration all have a direction, which is why we have the plus. Now, velocity is the derivative of the position with respect to time, and therefore when we take the derivative of this, we're going to get 6t squared minus 6t. And now we need to find out what the initial velocity is. And to do that, we're going to substitute t equals 0 again. And when t equals 0, the initial velocity is 0, and the units are meters per second. And finally, if we want to find the acceleration, it's the derivative of the velocity, and therefore it'll equal 12t minus 6. And when t equals 0, the initial acceleration, I should say, equals 12 times 0 minus 6, which is negative 6 meters per second squared. So now we have the initial position, the initial velocity, and the initial acceleration. The second part of the question asks us to find when the object is instantaneously at rest and determine its position and acceleration at those times. Now, it would have been handy had I not rubbed everything out, but let's do this quickly anyway. Instantaneously at rest, that means the velocity equals 0. So now let's quickly work out the equations for velocity and acceleration. If distance is 2t cubed minus 3t squared plus 8, then velocity is the derivative of that, which is 6t squared minus 6t, and acceleration equals 12t minus 6. Writing those down like that somewhere where you're not going to rub them out is probably quite a handy tip for when you're doing exams or something like that. So velocity equals 0. Well, we know, therefore, that 0 equals 6t squared minus 6t. And if we factorise that, we can take out the 6t and write 6t and t minus 1. Therefore, 6t equals 0, and the object's at rest initially, and t minus 1 could equal 0 using the null factor law, and therefore time equals 1. So when t equals 0, my displacement or position will equal plus 8 meters, and my acceleration will equal negative 6 meters per second squared. And that was actually part A. When t equals 1, my position will equal 2 times 1 cubed minus 3 times 1 squared plus 8, which equals plus 7 meters. And my acceleration will equal 12 times 1 minus 6, which will equal plus 6 meters per second squared. Notice how in all the answers I've made sure I include a positive or a negative, so I show the direction of the movement. If you found this video helpful, please subscribe or like. Thanks.